Hi guys, so let's talk about Azure SQL database scaling. So we have already seen these two features when I've showed you in the Azure portal. Now we'll look into some of the theoretical concepts. So first one is our vertical scaling and second one is horizontal scaling. So when we talk about vertical scaling, what are we talking about? We're increasing or decreasing the resources CPU memory allocated to a single database instance. And horizontal scaling, mainly it focuses on increasing number of database instances or replicas. So this is what we talk about in horizontal scaling. So we're increasing number of replicas, that is to handle more concurrent connections or ready heavy workloads. Now let's look at some of the examples of these two. So when we talk about features under vertical scaling and horizontal scaling, what it scales. So this one, it scales resources under the vertical scaling, resources, CPU memory, and the horizontal scaling scales instances replicas. When to use increased performance or needs, and for horizontal, it's when it's distributed load or high in demand. So when we talk about example, we need 2 or 4 vCores, and under horizontal scaling, it's adding more read replicas, right? So next we'll look into more of the theoretical concepts when we look into more of the vertical scaling. So we have already seen how it works. So we have scaled it up and down. We can move to a higher performance, that's from basic, standard to premium. We can scale it down, that is to, in order if you want to resources, in order if you want, if there is more lighter resources, we scale it down, right? So in another use case that we can use for vertical scaling is mainly when there is a database that is relatively small or has a predictable workload, or you need simply more power or memory for better performance. So example is upgrading from 2 to V for vCores to handle more complex queries. Now we'll look into horizontal scaling. So what is horizontal scaling? So how it works is scale out, and a term which is widely known in under horizontal scaling is sharding. So scale out, you can add more replicas to distribute read traffic. So what I will tell you this one. So imagine there is a database, so it will have more loaded with requests. So when there is more, when it is overloaded with requests, scaling out will help to distribute the load by adding more replicas to your database. And another, I can tell you, like imagine there's a single database instance. So you have single database handling all traffic. So as the demand will grow, that database will start to slow down, right? So to solve this, what we can do, we can scale out by adding read-only replicas. So these replicas, they don't handle writes, but they will handle read traffic. So the main database is less overloaded. And right, so across different regions. So when we talk about different regions, it's nothing but geo replication or active geo replication, that can be, which will allow me to place the replicas in different regions. So we'll look into that in our Azure portal. After we'll talk about this in theoretical, then I will show you in our Azure portal. So that's how, which will allow you to place the replicas in different regions, which will make the data more available to across the whole world or in our regions. And there is sharding. So when we talk about sharding, so it says splitting data across multiple databases to balance the load, not directly supported by Azure SQL, but can be achieved through custom implementation. So that is we have in our Azure portal. So when we imagine that if there is a database that is, if it is too large to scale out with replicas, so that's where the sharding term comes in. So in a sharded database, the data will be split across multiple databases. So each shard will store a portion of the total data. So for example, imagine there's a table of customer data. So you can split those into 2 shards, and one for customers in United States and one for customers either in India or Europe or wherever. Right. So the shard distribution, how it works. So each shard will work independently. So when a query will be made, it goes to the relevant shard. So helping to balance the load and prevent any database from getting too large or too slow. So that's what the use case is saying over here. Ideal for read heavy workloads or geographically distributed applications that need low latency. An example is adding read replicas for handling high volume queries while keeping the primary database for write operations. Now I want to talk about single tenancy and multi-tenancy. So single tenancy and multi-tenancy, it refers to how a service or infrastructure will be structured to handle multiple customers, referred to as tenants. And the choice between these two models impacts security, scalability, cost in Azure or other primary regions. So when we talk about single tenancy, single tenant means each customer. So each tenant, we call it as a customer. So they will have its own isolated environment. So I'll show you in this particular diagram. We can see here in our tenant 1, it will have its own custom resources and memories such as resources and own infrastructure. Database 2 has its own tenant, and similarly database tenant 3, 4, 5 up to 10 and n. So the resources will be dedicated exclusively to that one tenant itself, meaning that they don't share their environment with the other customers. So isolation. So that is one of the key characteristics when we talk about single tenancy. Tenants are fully isolated from each other. Each tenant's data, performance, all those will be independent, which means that there will be high security and customization. And when we talk about multi-tenancy, what we have. So in multi-tenancy, multiple tenants will share the same instance of an application of their service. So we can see here in database 1, tenant 2, tenant 3 have it. So that but their data and configuration will be separated. So all tenants will operate within the same environment. Similarly, for database 2, there is tenant 4, tenant 5, database 3, tenant 6, 7. Similarly, up to tenant n. So key characteristics will be resource sharing. So resources like CPU, memory, storage, all will be shared between the tenants. So this will allow for usage of resources, but also we have to make sure that there will be careful management to ensure isolation and fair distribution, resource distribution. Now we'll look into the differences between the single tenancy and multi-tenancy. So isolation. So complete isolation for each tenant, multi-tenancy, logical isolation. So resources are shared that we have already looked into. Security, high security and compliance flexibility for single tenancy. Multi-tenancy requires robust isolation and security controls. Customization, high customization for each tenant, limited customization option for multi-tenancy. So that's where single tenancy stands out. Scalability, limited scalability without significant infrastructure changes. So and multiple tenancy, easier scalability due to shared resources.
Welcome to LWP Labs. Subscribe to our YouTube channel to view free Azure DevOps live classes. And for more videos like this, please contact the number shown in the description. Happy learning!